now. All right, we're going to graph the function 4x minus 3 over x plus 8 by hand. We're not going to look at it on Desmos. We're just going to do what we've learned about vertical asymptotes, horizontal asymptotes, and then we're going to use long division to get the dilation. All right, so here we go. For vertical asymptotes, you take the denominator, set it equal to 0, and solve. Take away 8 from both sides. Done. Negative 8 is the vertical asymptote. So I can grab the line tool, go left 8, vertical line. So I know there's a vertical asymptote at negative 8. Step 2, horizontal asymptote. For that, you look at the degree, and you look at the fact that this one is balanced. It has an x on top and an x on the bottom. Neither one is squared or cubed or anything like that. So the ratio of 4 over 1 is where the asymptote will be. So there will be a horizontal asymptote at 4. If this bottom was 2x, the asymptote would be at 2. If it was 4x minus 3 over 4x plus 8, the asymptote would be at 1, because 4 over 4 would be 1. All right? So we can go up to 4 and put a horizontal asymptote and get ready to make our graph. Those two green lines are now the new center point of my two pieces of the hyperbola. In order to graph the function, I need to do a little bit of long division to see if there's a dilation and a reflection. So let's go down there and we'll do long division. X goes into 4x 4 times. When we distribute, we get 4x plus 32. And when you subtract this quantity, you get a remainder down here of negative 35. Whoa. So the remainder of negative 35 goes up here over the divisor. All right, so let's break this out over here and see what's going on. I have a negative 35 dilation. That sounds pretty extreme, but it's not too bad to graph. Plus 4. Okay, we already know that this was the left 8. Check. We know that this is the up 4. Check. This tells me the graph is reflected. That means that instead of being here and here, it's going to live here and here. That's what the negative will do. Now, how do we deal with this 35? Well, we just think of a pair of numbers, a pair that multiplies to make 35, 7 times 5, right? So here's a good way to graph this. Starting here at the origin of the hyperbola, the center, just go 7 to the right, 7, down 5. I know the graph will hit there. Then go 5 to the right, 7 down. I know the graph will hit there. If you had room, you could go over to 35, 1, and 135. You could go 17 and a half over and 1 down. I think we actually could. But at this point, once you have your 7, 5, and 5, 7, you could just make your curve like this. I'd be happy with that. If you can make these 2 points, and again, how did I get them? My horizontal and vertical change should multiply to make 35. That's how the dilation works with rational functions. The other piece of this is kind of up here off the screen, so I'm not worried about it. Let's move on. I just want to go boom, boom, boom. Step 1, vertical asymptote. 2, horizontal. 3, do long division. and deal with the dilation and reflection. So I'll turn the page to part B. I'll go double screen here if you need to get caught up. But I'm going to keep moving. All right, ready? Vertical asymptote. Set the bottom equal to 0, 0. Oh, mistake. 0 plus 1, everybody, is 1 when we add 1 to both sides. So now I know I have a vertical asymptote at 1. Horizontal. You kind of ignore these two guys here on the end, the plus 2 and the minus 1. Just look at 3x over x. Same degree, it would reduce to 3. Y equals 3 is the horizontal, so it's right there. This is the new crossroads of the asymptotes. That's the center of the two arms of the hyperbola. To figure out the dilation and graph it, we're going to take x minus 1 and divide it into 3x plus 2. How are we doing on time? Good. X goes into 3x 3 times, giving me a 3x minus 3 down here. After distributing. Now when I subtract this, these guys cancel. 2 minus negative 3 is positive 5. That is your remainder over that divisor. So let's check a few things. Right 1. Check. We already did that. Up 3. Check. We already did that. Dilation. This time it's positive, so it's not going to live south, east, and northwest. It's going to live in the normal quadrants up here and down here. If your dilation is 5, I could make 5 by doing 5 times 1 or 1 times 5. So all you do is you come here in the crossroads and you go 1, 5, 5, 1, make your curve. And I hope you did better than me. More like that. Sorry, I'm a little picky here with this. Let's get rid of that. And do the other arm. If you could put it on the graph, I didn't do it last time because it wasn't on the screen, but this time I can go from this crossroads, 1, 5, 5, 1. Once I have those, just go whoop, and whoop, and there's your graph. You could check them on Desmos if you like to see how we did, but I'm pretty confident that this is what you'll see. All right, I'm going to stop that